Good afternoon, everybody. Hi, my name is Kenny Gabriel. Today, I want to discuss a particular class with us, and that is set theory. And in this lesson, in this class, we want to look at the objective for this lesson, and that is by the end of this lesson, learners will be able to define the concept of set, state different type of set, and perform operations of set. Then, what is a set? Now, we said a set is defined as a collection of well-defined objects or distinct things. What do we mean? Is that the object we are bringing together, maybe they are using for a particular uniquely something, then those set is what refers to as what? The collection of those objects is what refers as a set. For example, now, collection of mathematics teachers, mathematical instruments, set of simultaneous equations, and so on. And set is usually denoted with the capital letters, capital A, B, C, and D. Why? Before we go to start, every set has an element, and that's why we say that element of a set is the member of the set. Now, look at these are examples of a set that we can see. We can see the picture we have here. We have here now we have, you can see that we have something here. Now look at this. This circle here, look at this, a cup, a bowl, comprises of a fruit. For example, say this B comprises of what? The apple, the orange, the pear, and basically we have banana. So these are the things that this cup is. You can see that this one can be reversed as the connection of a fruit, which means can be reversed as what? The set of fruit, because this bowl labeled B comprises of what? The apple, the pear, the banana, and the orange. So those are the one you can start another example. Let's look at this picture, another this second picture here. And this second picture also has that it's a collection of set of fruits here. And this set of fruit, we have blueberry here, we have watermelon, we have different kind of fruit that be connected together. And that is why we also revise as what? As a set, because they are bringing together the connection of what? Of a fruit. Likewise, when we look at the next picture here, even by looking at this one here, we can see that we have set X here. In this set X, we have 2, 4, 6, 8, 10. This is a set also. This is a set of even number ranging from 2 to 10. The second set is a set of odd numbers. And the combination of the two also form the set of what? Of integers from 1 to 10. We can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this also is an example of a set. Now let's move on to the next part. So let's move on to the next part of the. Sorry for that disturbed. Now, let's look at the type of set. Now, we're talking about the type of set. What does it really mean? We discover that sets can be defined into different categories. We have finite set. A finite set is a set that has finite number of elements. That is, the set of elements that has that a set of elements is set whose members are countable. That is, you can actually count the number of elements of that set. And such a set is what refers to as what? A finite set. For example, we have this set now. We have a set of x such that 2 is less than or equal to x, less than or equal to 12. And x is what? Is an integer. So that is, by the time you want to list the element of this set, let's want to list the element of this set now. We're going to have something like 2, because don't forget that 2 is inclusive. It's inclusive here because 2 is less than or equal to, start from 2, then followed by what? 3, because it's an integer, followed by 4, followed by, we have 5, followed by 6. That's set A now, 7, 8. We have 9. We have what? 10. We have 11. And we have what? Last element here is what? It is 12. So, and we can see that this set of elements is what? Is finite, because you can actually count the number of elements in this set. For example, now if you count one after the other, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means this set comprises what? 11 elements. Even by knowing the number of elements of a set, without as what? The cardinality of that set. No, cardinality of a set is a total number of elements in that set. So that's one. This one is just for a list of elements for what? For set A now. Now look at this set B. Set B here. Also, before I move on to describe the concept of set B now, note that set A is also banded below and banded what? Above. That is as starting from the lower band, I have a minimum value of 2 and maximum value of what? Of 12. So then also we have B. Now, B is already listed the element set. This is another example of what? Of a finite set. Now, but when you look at the next one, which is called infinite set, so this is a set whose members are not counted. Examples are, look at this. You can see that it started from ... -1, 2, 3, 4. Now, this set A now is what? An infinite set, because the set of elements still continue from what? From below. Because that's why ... still continue from below. Then look at B also. 1, 2, 3, 4, 5. It's also continue like that. Now, we're going to see now, it can also continue from below. So that means we don't know where it starts, neither we know where it ends. But in set B now, we know where it started, but we don't know where it ends, because the value still continue. And that is why it is referred as what? Infinite set. The next one we have, you can see the one is we don't know where it started from the below, but we know it where it ends at what? It ends at 4. So this is referred as what? Infinite, another of infinite set. Then another example, another type of set we have, we call it empty set or null set. So this is a set that has no element. An empty set is what? It's a set that has what? No element. For example, all Nigerians who are 400 years old. You can see that there is no way we can actually see Nigerians that's what? Older than up to 400 years. Even those are the example of what? Of a null, of a of empty set. Now, another one that you want us to look at is let's quickly look at operations of set. Operations of set. Like an operation of set. Look at some operation of set. Please, just a minute, please, and let's erase this one out. Now, let's quickly go to operation of set. Now, when you talk about operation of set, what does it really mean? What does it mean? Now, we look at the first one. Let's look at the subset and the superset. Now, I usually like explaining the concept of subset and superset in terms of what you are familiar with. When you talk about inequality, and this is where you talk about less than and less than or equal to. For example, now we look at, when you say if value is less than, or value is what is greater than. You know, for example, now when you look at, you can actually see that 2 is what? Is less than 3. Abi? I think I remember that one very well. Then also we can say that 4 is what? Is greater than 3. Now, the notions that we have here actually help us to explain the concept of subset and superset. When something is sub, something that's very low, below. And when say something is super, that want to have the kind of super, something that is higher or has a maximum value, maximum, that's very maximum. Let's say maximum. Sub means minimum. Super simply means what? Maximum. Now, when do we say we have a subset and when we have a superset? Because we are going to set now. You said set A is said to be a subset of set B if every element, look at that word. Every element of set A is what? Is an element is contained in set B. What are we saying? Now look at this example here. Let's look at this diagram we have here now. You can discover that here you can discover that we have a set A here. This is set A. Can we see set A now? This is a circle that is pasted with pink color. That's set A, and we have this one called with sky blue. We have set B here. Now we can discover that A is a sub of what? Of B. That is, all the element of A here is actually contained in this set B. That is, you can find all the elements of A in set what? In set B now, and you can see the picture here now. But when you look at this set here, a set is that contain all the elements of another set. That's based on what? Superset. For example, look at this. This set A here. Look at this set B. B, the set of elements B is what? 1, 3, 5. Look at the set of elements in A. 1, 2, 3, 4, 5, 6, 7. And we can see that 1, 3, 5 also can be found in what? 1, 2, 3, 4, 5, 6, 7. So in this case, we're now saying that here, based on this figure we have here, we say that A is a superset of B. Then B is a sub of A. I want to take note of that word very, very well, that you have B, something that is superset, very B, something that is in normal inequality sense. You can say that A is greater than B, or we can say B is what? Less than A. So that is why it's simply applicable here, that I can say that here, A in this figure here, sorry. Now look at this one now. In this place, we can say that based on what we have here now, I can say that A is a what? Is a sub of B. Can you see that? So in this place, A is sub of B. But when it comes to this place now, we say that A is a what? It's a superset of B. Don't forget, this symbol means what? As this symbol you are seeing here. This symbol here. Let me quickly check something. This symbol, this one you are seeing, this symbol here, this symbol is referred to as what? Super subset. Why this symbol means what? Superset. I think you can see that now. I want you to get this very well. So if it is not clear to you, please try as much as possible to drop your question into the comment section. You can see comment section. Try as much as to drop questions that if it is not clear to you. So I want you to look at it very well now. Can you see that this refers as what? A subset, and this one as what? A superset. So that is how you can differentiate between the two. Now, I want us to go another part of the work now. Now, let's look at the operation of sets. And this operation of sets here we refer as what? Union of sets. Now, let me explain the concept of union. What does union really mean? In a literary English, in a literary words, union simply means bringing objects together or bringing people together to form a body. For example, in school, we have union of students. We have student unions. We have student union. We have Nigerian Union of Teachers. We have different kind of a union of people coming together, like transport workers. They form a what? A union. Nigerian Labour also form what? A union. So everybody has their whole union. Now, when you're talking about union simply means that bringing peoples together. That is, what is in set A, also in set B, or is either in set A or set B, or both in what? A and B. That is, we look at some elements that are common to them, whether you now bring them together, and that is why we refer to as what? A union of a set. For example, now look at this one. For instance, when we look at this object here now, we can discover that set A comprises of a pentagon, a square, rectangle, and triangle. While set B comprised of what? Triangle, star, and what? And pentagon. Now, when you look at the two now, we are talking about the union of two of them. You can discover that pentagon is what? Is here. It's also here. You can pick one. That's why I can have a pentagon, pentagon, square, square, rectangle, rectangle, triangle, triangle. You can see that. So you are bringing them together. So in the nutshell, you can actually, you don't need to repeat any of the shape again. That's why first of what? A is a union of B. But when you look at intersection of set of two sets, the set of elements that belongs to both A and B. That it belongs to set A and also belongs to what? Set B. So that is what you can see these Venn diagrams now. This is set A here. You can see this for set A. This one is for set B here now. Can you see that? So, and then you can see the where both of them overlap is this place that is shaded with red. This red region is the area that describes the intersection of the set of elements of what? A and B. Now, in coming back to this first figure here now, I can actually show, you can actually see that the set of elements, the set of objects or the objects that is common to A and B are what? Look at it. That's it. Look at this one. This figure is also common, Abi. That's pentagon. And that's talking about what? Intersection. Likewise, triangle here and this triangle. So that means if I want to find A intersection B for this figure we have here, the set of units that come to both of them is what? Is pentagon and triangle. That is the intersection of these two sets, A intersection B. Those are the operation of what? Operation of set. Now let's look at another operation of set now. We have complements of what? Of sets. Complement of sets. Now, when we talk about complement of sets, you have inverse set. You have discovered what inverse set is earlier. Inverse set is a set that consists of all other sets of the same interest that are used for the same explanation. Now, for example, say given inverse set and a subset of universal set A, then the complement of set A is a set of elements that are in what? Universal set, but not in A. And by that, you can see this one very well now. Look at this. I want to take something here. Now, look at this one. Look at this. Then you can see that in this case, you can actually see that the shaded region here, this shaded region here, is the required region that describes the complement of the set. That is, those are the set of elements that are in this set A and that not in this set A. You can see the set A was shaded with white color. This was shaded with blue color. This area that you are seeing is what refers to as what? The complement of that set. And that's why it's denoted by what? A prime. You can see A prime here. So let's say for instance now you have inverse set U. You have inverse set U to be a set of let's say I have 1, 2, 3, I have 4. Let's assume that I have 5 now. I have 5 like this. So if I want to find, and you are given a set A now, then I'm giving a set A to be 2. Let's say you have 2, 3 now. So this is set A now. So in this set A, what can you say? You see that if I want to find this A complement, I'll just remove the set of A, that is 2, 3 from this given set. So that means you're having your A complement will definitely give you what? A set of, let's check it now. So, there is 2 here. So remove 2, 1, you remain 1, you remain what? You remove 2 and 3, you remain 4, and what? And 5. So this is what gives you what? A complement of a set. That is, you just remove the set of A from U. The subset that remain that give us the complement of that set A. Now, let's move on to difference of sets. The difference of two sets A and B denoted by this, A minus B, is the set of elements in A that are not in B. So any set of elements that are present in A now, look at this one now. This, let's say, for example, now you have a set A. I have a set A to be given as, let's say I'm giving a set A to be, let's say you have 1, 2, and I have 3. Let's say I have this set, for example, now. Then, and you have a set B, given it to be what? You have a B like this, and that leads you to, you have, let's say you have 2, 4. Let's, for example, have 2, 4 now. So if I want to do, look at it too, A minus B. Sorry, I want to do this one, A minus B. A minus B will just give me, I will remove element of 2 from here. So what remains there is what? 1. No, 2 is here. I will cancel it out. I have 3. So this is what gives you what? This is the set of A minus B. So suppose you want to put it in this Venn diagram, for example. Now, you know, I have set 1, 2, 3. The element is common for 2 of them. Yes, 2 is common. I can add 2 here. So element remain what? 4 here. So what's remain for 3? I have 1 and what? And 3. So you can see the Venn diagram now. So A minus B will then give us what? A O, you know, in the normal sense, we call it as what? A only, A only. And that's why I have what? 1 and 3. So here now we have 4 here. If I want to find, okay, if I want to check it now, B minus A. Let's B minus A now. I know you give it, tell me the answer to that one now. So what is the element that in not that only in B only? You see that is set of element of what? You can see when you look at B only, that is 4. You have a 4 here. Can you see that? So that is for B minus A. So why this was for what? A minus B, that's 1,3. This for B minus A, we have 4 here. So that's one that gives us the complement. I mean, we are able to understand the concept of what? Complement of sets and what? Different of sets. So let's quickly go back before we round up for the next part. Now, let's quickly go. Now, look at another one that we want us to check out. Check another one. I think we'll be able to explain some concept about set theory. We will talk about set theory now. Now, you can see for today, we are able to understand the concept of set theory. We're able to know what the definition of each of the type of set we have and how we can perform the operation of the set. Now, in the next video, we're going to be looking at some examples of how we can perform operation on set. I will look at more examples on that. So we're able to see it one after the other, how we can actually find the union of these two sets. Even if you are doing 3 sets now, how can you determine the intersection, the union, the complement, and some other set algebra? We look at that one in the next class. I want to make sure that if you have any question that's not clear to you, feel free to put in the comment section. Also, you can also send your email to the WhatsApp number you can see there. This is my WhatsApp number. You can send your email to that, or also you can actually send your comment to email that follows like that. So thank you very much. Happy to see you. I'm still your math teacher, Kehinde Gabriel Ilori, Dr. Kehinde Gabriel Ilori. Thank you very much and have a wonderful day. Thank you.